Welcome to News About Geology. Today, we're going to dig into the incredible journey of a modern geochemist, from the rugged fieldwork all the way to the futuristic lab, and find out how they read the stories written in rocks to build our future.
So, what does a geologist actually do all day? I mean, if you're picturing someone with just a dusty rock hammer out in the middle of nowhere, well, you're only seeing a tiny piece of a much bigger, way more dynamic story.
Yeah, this quote from an exploration geologist really says it all, doesn't it? One day it's Kazakhstan, the next it's Finland or Spain. It's this incredible mix of intense fieldwork, late nights staring at samples, and, passionate arguments about what the rocks are actually telling us. It's a job that is absolutely fueled by curiosity.
And believe me, the career paths are as varied as the Earth's crust itself. I mean, geoscientists are absolutely essential everywhere. You'll find them on the front lines of mineral exploration, in the halls of government, advising on environmental policy, managing our critical water resources, and of course, pushing the absolute boundaries of what we know in academic research.
All right, so where does it all begin? Well, the journey of discovery always starts out in the field. And out there, careful, systematic observation is, it's everything.
Look, every single geologist starts with an essential toolkit. And these aren't just for show, They're the instruments you need to capture precise data right there at the source, making sure every single critical detail gets recorded accurately.
The classic techniques are really the bedrock of the profession. We're talking about things like taking a bearing with a Silva compass to measure exactly how those rock layers are oriented, or creating incredibly detailed field sketches to capture the relationships between them. These are the fundamental skills you use to build a geological map, literally from the ground up.
And this is where you see the perfect fusion of old and new. Modern fieldwork literally brings the lab right to the rock face. A portable XRF analyzer, just like this one, gives geologists instant chemical data. That means they can make critical decisions right there, on the spot. It's a game changer.
Okay, so once those samples are collected, the real interrogation begins back in the lab. This is where we start to unlock the chemical secrets that are hidden deep inside the rock.
So, how do you analyze a rock with these super high-tech instruments? Well, first, you gotta dissolve it. You have to turn that solid rock into a liquid. This process can happen a few different ways. You might use what's called a partial digestion, like Aqua Regia, if you're targeting specific things like precious metals. Or you could go for a nearly total 4-acid digestion to break down tougher minerals. And for the really stubborn stuff, you use high-temperature fusion to melt the entire sample down for the complete picture. All right. So now you've got your rock in liquid form. This is where one of the most powerful tools in the geochemist's entire arsenal comes into play. It's called inductively coupled plasma mass spectrometry, or let's just call it ICP-MS. And trust me, this is where things get really impressive.
So how on earth does it work? Well, that liquid sample gets sprayed into an incredibly hot argon plasma. And when I say hot, I mean we're talking 10,000 Kelvin. That's hotter than the surface of the sun. This absolute inferno just vaporizes the sample and ionizes its atoms. Then, those ions get pulled into a mass spectrometer, which sorts and counts them, literally one by one.
What's just mind-blowing about this technique is its sensitivity. Just look at this periodic table. ICP-MS can detect pretty much every element, often down to the parts per trillion level. Now, to put that into perspective for you, that's like trying to find one single specific blade of grass on an entire football field. The precision is it's absolutely astonishing.
Seeing these real-world applications is just fascinating. And hey, if you want to see more awesome geology in action, you should definitely check out the YouTube channel of PGO Ricardo Valls. He does a fantastic job of breaking down these really complex topics. So, you get all this incredibly precise data from the lab. What happens next? I mean, it doesn't just sit in a spreadsheet, right? Of course not. It becomes the fuel for these powerful computer models that help us understand the Earth as a complete, dynamic system. This is where geochemists use some really specialized software to turn all those raw numbers into meaningful insights. So on one hand, they can simulate incredibly complex Earth processes, like, say, how water interacts with rock over millions of years. And on the other hand, they can analyze these enormous data sets to find hidden patterns that your naked eye would just never, ever see.
And this digital toolkit, this is what lets geologists answer some of the most critical questions out there. I mean, By using programs like these, they can actually predict how contaminants might move through our groundwater, or they can model the formation of valuable mineral deposits deep, deep within the Earth's crust. It's powerful stuff.
So, okay, all of this brings us to probably the most important question of all. Why? Why does all this work? From the field, to the lab, to the computer, why does it matter so much, right now, more than ever?
Well, for starters, the demand is just surging. Job growth for geoscientists was projected to be around 14% over a decade. Now, that is significantly faster than the average for all other jobs. The bottom line is, the world needs people who can read the stories written in rocks, and it needs them now.
And a huge, huge driver of this demand is the transition to green energy. You know, as this geologist puts it so well, you can't build a sustainable future without a massive supply of critical metals and minerals. And it's the job of skilled, ethically minded geologists to discover and help extract those resources in a responsible way. That's the key. And that right there, that is the vital connection. The work of a geologist directly links our planet's ancient past to the biggest challenges and the biggest opportunities of our shared future. They are literally reading Earth's history to help us write what comes next.
And hey, before we sign off, if this has sparked your curiosity, and I hope it has, don't forget to go check out PGO Ricardo Valls' channel on YouTube. You'll find some great stuff there.
Thanks so much for watching News About Geology.
My name is Ricardo Valls. I am a professional geologist registered in the province of Ontario, Canada, and also the president of Valls Geoconsultant. Geology, geochemistry, structural analysis, machine learning, and artificial intelligence. I am sure you will find something useful among my over 550 videos.
YouTube elimina la barrera de los idiomas. Ahora ya puedes oír los vídeos en tu lengua materna aunque estén en inglés. Sigue estos pasos sencillos. 1. Abre el video en YouTube que quieres mirar. 2. Haz clic en el icono de los subtítulos. Parece una pequeña CC, está abajo a la derecha del vídeo. Si los subtítulos están en inglés, haz clic en el icono de configuración, el engranaje, también abajo a la derecha. 4. Selecciona Subtítulos y después elige Traducción automática. 5. Busca y selecciona Español en la lista de idiomas. ¡Listo! Ahora puedes ver y entender cualquier vídeo en inglés, con subtítulos en español. Así, YouTube te ayuda a aprender sin importar el idioma original del video.
I think these videos are brilliant, and I'm sure you will like them too. Please like, comment, and subscribe, and don't forget to click the notification bell.